My name's Keegan Neve of the Neve Engineering blog, and I'm here today to talk to you about a Nerf gun shooting gallery I've recently made. Arrayed here beside me. The idea was to build this game for the games team for the Reading Beer Festival, which was held last weekend, and it mostly worked. I tried to build this last year and it didn't work. This year it actually lasted all weekend. Not without a few quirks, which I'll talk about over the course of the video, but nominally it worked. It went down a storm. Incredibly proud of it. Loads of people had loads of fun with it, which was always great to see. And yeah, it's a work in progress. Considering I started work on it a couple of days beforehand, despite having a year in which to actually get the damn thing working. Of course I didn't, because I'm me. And there's no cure, but why would there be? And this is the result. So the backboard is, or the game board is laser cut at Reading Hackspace, rlab.org.uk, and each target has a servo, a sensor, an LED. So at the minute it's in what I call attract mode, which is a thing that arcade machines have and pinball machines. So they flash up, they flicker, they get your attention, they suck you in and then get all your money, which is fair. That's what I was aiming for. So at the minute it's just going cycling using one of the fast LED libraries, random rainbow modes. But it's got a bunch of buttons down the left hand side, and I'll go into greater detail with where the buttons are, what they do, and all the kit involved later on in the video. But nominally you press the start button, goes through and resets all of the targets in case they were knocked down but not reset. You take a Nerf gun, you go to a safe distance and you shoot it and hopefully hit. Now we've got fives, we've got 10s and 125 point thing in the middle. We have a gauge up the left hand side, which it has a servo in it, and an arm with 0 to 100, and an LED behind it which changes colour depending on what level you got to. Bye Willow, it's my cat. To make it easy for the games team. So the idea is that you've got 3 different levels of tickets. You've got yellows, blues and reds, and as you get more points you get better tickets. More points mean prizes. And I just thought it'd be nice and easy that depending on what level you get to, we could pre-program it to make it easy for the games team, because they've got a lot of work on. They work their asses off at that festival and I've no idea how they do it. I get tired just watching them. But yeah, so I think it was 35 for yellow, I think we decided on. Blue was 50, and I think when you got to 70 or 65 you got a red ticket, and that's it really. That's the whole premise of the game. You shoot it, you get points, you win a prize. A few things that cropped up over the weekend. For one thing, sun was my enemy. Not only the red top newspaper, which is trash, but the actual fiery sun god. It was just a pain in the ass really. I mean, it was great for the festival because we had loads of people there, but the sensors on here are infrared, which is great because, you know, there's non-contact. It means that they'll last longer, they should be more resilient, they should just work a treat. So when the target passes them, goes, oh look, something's changed, someone must have scored points, reset, give them points. The only problem is that I developed this here, inside, in my flat, mostly at night at stupid o'clock in the morning, with the curtains closed. Not that that made a difference. My window's north facing, so I get cockle light here. But yeah, it worked a treat until I got to the beer festival, which is in a giant marquee. And the sun was out, probably one of the sunniest and hottest days of this year so far. And yeah, all of the sensors just completely crapped out. And it took me a while to realise that, yeah, it was because they were infrared and I had this massive fusion engine, 98 million miles away-ish, causing me problems. Ended up constructing a cardboard box around the target as an enclosure with a couple of black bin bags in there just to absorb a bit of the light, and created a different set of sensor sensitivity values for day and night. These sensors, I'm getting the raw values from them. They're the Pololu QTR1As, I think. Link down there to my GitHub page with all of the actual links on it. And I'm getting the raw values from this. It just seemed easier because I couldn't quite get my head around how to use the library any other way. Like I said, this was mostly programmed at stupid o'clock in the morning while sleep deprived. And yeah, so basically if value above certain number, target must be down. Simple enough. So I had two sets of sensitivity values, and what you could do, because basically in the daytime we needed sensitivity to this value, so you know, value goes above 5 and you've hit the target. By the time night drops, it's if the target goes above 60 or 100 or whatever it is. So we needed to switch between the two. And on the first day, which was a Thursday, I manually reprogrammed it. I have my laptop with me, still not without its quirks. Which leads me on to another problem quickly. It's just reset, bugger. Sometimes they weren't resetting, so I put a reset button on there. So the idea is it goes through and resets all the targets without resetting the score. It's a feature request on day 1. So that was quite fun, just kind of hacking this together over the weekend, to be honest. It was a lot of fun. But the sensitivity values. So if you switch it into attract mode, the down button, I don't know if you can see this. Yep, flashing yellow. What that yellow means is that it's in day mode, which lowers the sensitivity. And when the sun goes down, press it again, it flashes purple to say it's nighttime. And that's it. It's just an array of 5 values, 1 for each sensor. It swaps them out. And that, I think, was the biggest problem. The nature of this is that it was mostly hot glued together, some of which failed. Some of that glue was actually on there from the previous year, because like I say, this is the same board I used for last year. Targets are the same. The hinges were completely redesigned. But yeah, some of the glue failed. Like I say, it was a hot day as well, so the hot glue just kind of came off. Some of these were reattached using Gorilla Glue, just because I knew it needed to last the weekend, and it did. And yeah, so those were the only 2 problems: was the targets falling off, should I say, and the sensors failing. The other big problem we had, which isn't my fault, these aren't really designed to be shot constantly for like 4 days. We had a problem where this would jam, which was annoying, incredibly annoying. And for next year, don't know what I'm going to do for that. It'll be a NERF-based gun of some kind, maybe one of the automatic ones, just because of the way the internal mechanism works. Maybe one I make myself, just for the hell of it. But yeah, that that jamming was a big problem for the games team, so that is one of the big problems I'll try and fix. Luckily, though, there are quite a few of us nerds on there, which have NERF guns. So I think we ended up buying not Retaliator, the Renegade, the 6-shooter, which the barrel. Let's just switch the sensitivity on that one to day mode. No, I don't know. It's just going to carry on doing that probably. The barrel is essentially the magazine, so it shoots straight from the barrel, which means it's considerably simpler. That one seemed to work a lot better, but we still occasionally had the darts just falling out. But yeah, those are the big things. Sensor-wise for next time, I will use Hall effect sensors. Never used them before, but considering that there's already a magnet in here holding these targets up, it just seems like a no-brainer. It's what I did want to use this year, just because I just wanted to use Hall effect sensors. I like magnets. I've got an induction hob. I cook using magnets. It's brilliant. Nerd, no surprise. And yeah, so that'll be it really, and that'll take care of the problem with the fiery sun god. And yeah, I'll now to dig in a bit into the actual mechanism. Okay, so this is the back side of the target, and you can see it's still in attract mode, and it's a mess, but that's fine. It only really needed to last a weekend. It looks like it's going to last a lot longer, to be honest, but yeah, it'll be redone before next year. So what we have is, for one thing, a wonderful enclosure to keep the electronics safe. Yes, this is a takeaway container that I've cut some divots out of where the cable's kind of trunk together. It works. You know, and the last thing I wanted was someone to just come and yank all this out, because that would have just been incredibly annoying, to put it incredibly politely. So what we have here is an Arduino Mega with an Adafruit PWM servo sheet on top. Originally I just wanted to use one Arduino, but the the fast LED library that I use, and any of the WS2811 RGB LEDs, they require incredibly precise timing. The only problem is that servos, the standard servo library for an Arduino, also requires incredibly precise timing. So it's very difficult to use both at the same time. There is a way around this. Adafruit have a library that allows you to use both, which does work very well. The only concern there is that it requires you to use very specific pins for the servos, and reduces the accuracy, the range of values that you can set servos to. So I quickly ditched that idea purely for the fact I wanted simplicity. So I added the Adafruit board. It's 16 channels, I believe, for servos. At some point this is going to get more complex, so I figured this is future proofing, and I'm always going to use servos, you know, for robotics and all the rest of it. They're just handy. So this one only has 6 at the minute, so we've got plenty of overhead. But other than that, there's no real custom electronics. It's mostly just wiring loom, and that's it. So starting at the top right, we have 4 buttons. So I don't know how well this is going to show up, but shows up just well enough. These are actually originally from my car PC. Way back when I built a car PC. Thank you, Servo. That was an incredibly valuable contribution. So this was actually from my dearest Neville, my old Vauxhall Corsa, my first car. This sat in the ashtray, had 12 buttons, which were, this is just a USB gamepad in there, and each of these was mapped to do a different thing. So you had start, stop, next, previous. The blue button was the power switch for the computer, hence being illuminated. That red switch, never actually did anything with it, but it was just fun to have the option. And I think this was taken from the front cover of an NTL cable box, just because it was a random bit of plastic that I could drill and vaguely fit. Yeah, just plugged into USB, job done. Kept it around because buttons are useful, and thus they proved. So the illuminated reset button does what it says on the tin. It switches between the different modes. So when you're in attract mode, you press it, it'll go into playing mode. When you're in playing mode, you repress it, it'll go through the reset mode into attract, and rinse and repeat. The other buttons, depending on what mode you're in, they have different actions. So this top one is always target reset. So you press that, it'll go through and reset all of the targets to make sure they're upright, because sometimes they got in a funny state where the target was down, but it hadn't detected it was down, it thought it was still up, or vice versa. This just sorts all that out without losing the score. Middle button I don't think actually does anything. The original idea was that that would be the set button, and that would be up and down, and you could change the sensitivity of the sensors, the level at which you get different ticket levels. So you could set, manually set that without having to reprogram it. Again, it was trying to make it that bit easier for the games team and not need me to be there to reprogram it and all the rest. So yeah, the middle button doesn't do anything. Bottom button, when you're in attract mode, you press that and it changes between day and night modes. Moving on slightly, we have the points gauge. This goes from 0 to 100, just to show the current level of points you're at. When you get to 100, it turns all of the LEDs red and the counter LED starts flashing, just to say you're there, you're done, you've got a higher score. Again, for the next version, this is going to be some kind of digital display. That's a way away yet, but we don't want to be limited to 100 basically. But yeah, so it's got WS2811, and I might be getting this wrong, pretty sure that's what it is. RGB LED, they're daisy chained, so they're only using one pin, and it's sending a signal across them. And below it is the servo, which controls the arm, which moves the arm to show how many points you've got. Again, it changes colour depending on state. That's much of muchness really. So onto the targets, and from here on out, they're essentially a variation on the theme. So I'll zoom in and show you one of them closer up, and that's it for the buttons. They're just wired. They've got a common ground, and they're wired into 4 pins. The internal pull-up was enabled on there just to make it to debounce it essentially, which worked an absolute treat. So this is one of the targets. This is number 5 pointer, I believe, and it's got a couple of components. So it's got the hinge mechanism down here that hosts the sensors, and the servo and the actual axis along which it drops. There's a little rubber foot, typically goes on the bottom of an enclosure, and that just dampens it so it doesn't put as much shock load, if that's the right phrase for it, onto this hinge when it drops. I'll just undo this quickly to show you the rest. So that's annoying because you can't actually see it, but what we have is on the back here is a small magnet. I had a sheet of fridge magnet essentially, so you could just cut out whatever shape you wanted to make a magnet out of and job done. Part of the design is that it has a slot for a penny, because they're made of copper and magnetic, so it just works really nice. So yeah, that just holds it up quite nicely. Next to the arm is one of the infrared sensors, and the nice thing about these is that they actually have a little hole in them just next to the servo. So the little arm, the little slot that these slot into, and all of these are for the axle use cocktail sticks. Cocktail sticks are absolutely brilliant for random things like that. That and chopsticks. I always keep loads around, and basically when you put the cocktail stick through the hinge and into the thing, that just holds it in place. Not specifically designed to do it, it just worked out really nicely, but hey, I'll take serendipity when it smiles on me. And underneath that is the servo. That's just screwed in from one side with an arm on it. This is the same arm used for the counter. It just worked, apart from one of them, which was from a previous version, which was super glued on there and I couldn't be bothered. It worked, so why break it and all that. And the next to it is another RGB LED. When the target is down, it's red, showing you that you can't, if you shoot it, you won't get any points. And when its points are available, it turns green. Other than that, it was all powered from a USB battery pack. I think this is 12,000 milliamp hour, 12 amp hour. Why don't people just say 12 amp hour? Battery, and I was expecting this to be used up over the course of the first day, but nope. After the entire weekend, and I've not charged it yet, it's only used half of it. And that's it really. We've got a few things to note. Is that these sensors, they've got a common ground and a common emitter pin. So the idea is that the wiring loom for these daisy chains. So when the emitter pin is enabled, which I can't remember which pin it is, 42 I think, all of them flash at the same time. The Arduino then cycles through them and gets the values for each, dumps them into an array, and then you can do something with it. For the LEDs, again, they use one pin for data, which gets daisy chained through them, because these LEDs have 4 pins, positive voltage, ground, data in and data out, so you can just nicely daisy chain them together, which made the wiring a little bit easier. Essentially, the Arduino Mega is massively over-spec'd here because we're only using a handful of ports. The place it was invaluable is with the analog inputs, however. So on Arduinos, the pin 0 and 1, I think it is, on analog are used for I2C. I2C is used by the servo board for the communication method, which meant that I only had 4 analog inputs left, I think it was, which just wouldn't work. Luckily, I had this Arduino Mega lying around, so just threw it in there and went brute force with it. So the extra analog inputs were ideal for this. So that was pretty much the limit of how many sensors I could have on here. If I went with Hall effect sensors, I might be able to use digital pins instead, or if you used different types of sensors, you'd be good to go. So one thing I mentioned only briefly was the power pack. Like I said, this is a 12 amp hour USB battery pack, which was ideal for this. For one thing, it has 2 inputs, because the Arduino is powered by one of them, and the servo shield has a 5-volt input. Some servos, especially the high torque ones, can take an awful lot of power when they're under load, so you'd burn out an Arduino in no time if you tried to use the 5-volt rail from that. The other benefit there is that the LED's 5-volt source I wired into the same place just for the same reason. I had no idea how much power these were going to use. It turned out to be nothing, but still better safe than sorry. So yeah, we'll just show it firing up. So we've got 2 USB cables. Press the button to switch on the battery pack. It goes through its startup routine, and that's it. So what it's done there is it's gone through and set up the serial port, which I use for debugging. It's set up all of the LEDs, the servos, the sensors, created whatever variables are required in memory, and then it just loops through. So it just keeps track of the states, and again, the code's in the link below to my GitHub page for more details on that. And that's it, really. You know, you hit the target, it resets, and when you're in game mode, it keeps track of that. So nice and simple, really. It just the servo just goes between maximum, minimum, resets it, stays up there just for a second to make sure the magnet's engaged, and that's it. So it's a lot of moving parts, a lot of wiring, relatively speaking, but it's actually quite a simple board. So if anyone wanted to have a go at this, please feel free to use this as a base, but do use it as a base. And that's about it, really. So we've got USB voltage for power, a USB battery pack for power at USB voltage. We've got an Arduino, we've got the shield, got a bunch of hobbyist servos, the 9G ones. Can't remember where I got them from. I think I bought a box of them off eBay. A bunch of RGB LEDs and some buttons. If you don't have access to a laser cutter or a 3D printer, the 3D printer would be a problem. I've included the STL files so you can send them off and get them printed if you wanted to, if you didn't have access. Otherwise, I would strongly recommend you find your local hackspace and get involved in the maker community. Sounds like I'm taking the mick, but do it. If you've got a hackspace nearby or a makerspace or whatever you want to call it, they're brilliant resources. I hate the term resource, but the amount of information a lot of these people have, it's proven invaluable to me. I wouldn't have got this far without help of the people at the Reading Hackspace, rlab.org.uk, as previously mentioned. So yeah, I mean, like I say, you can pretty much cut the board out using a jigsaw if you're careful. But yeah, the hinges is quite complex. So I'm not sure if you could make that by hand, but like I say, shapeways or 3D hubs, things like that. There are services out there that could probably print these out cheap enough. And the few pitfalls, like I mentioned earlier, the sensors were problematic to say the least, and the board itself. This was the first thing I laser cut, and the result of that was that I didn't know that when you load a file into RDWorks, which is the software Laser uses, it doesn't always respect the scale. I'm not sure why. I don't know if it's a setting I keep missing or not, but it scales everything down by about 7%. So it looks about right on the screen, but unless you check, you can't be certain. But you should always check every time anyway, right? Something like that. So when this was printed out, this was supposed to be a certain size, and it wasn't. When I laser cut it, each of these circles was slightly smaller than they needed to be, which is why if you go through the files and if you use my files verbatim, it won't fit. So that's just something to be bear in mind. And I'd say I've learnt from a project I did recently. I rebuilt my guitar, made a custom scratch plate, which was laser cut, and the scaling I didn't get right there the first time either. I thought I did, and I assumed that I'd messed up the measurements, but who knows. That guitar now looks brilliant, but I'll cover that in a different video. So yeah, just be very, very careful that when you make your own board, you measure everything, you customize everything as required. Like I said, in the GitHub repository, link below, probably, I'll put it down there somewhere. There is not only the STL files, but there are also the OpenSCAD files, or OpenSCAD. I can never really know how to pronounce that. So if you want to make these arms longer, they're parametric, you can just change the length of the arms. Same with the actual covers for the targets themselves and all the rest. So yeah, if you end up making one of these, please do send me a link, because I'd love to see other people using my work. I've learned everything from seeing other people. You know, they've shared things on YouTube, they've shared things on their own blogs, and the massive resource that is Adafruit. So I can't thank them enough for helping me out over the years with the documentation and their tutorials. It's absolutely superb. Check them out. And yeah, I've learned by standing on the shoulder of giants. So if you can do something and improve it, submit a pull request to my GitHub repo, or just send me a link to the stuff you've done, and I'll say, and if it's something that I think it will be an improvement, I'll backport it, and we can all improve together, because, you know, life's more fun when you work with other people. But yeah, that's about it really. I've rambled. I've no idea how I'm going to edit this video, probably badly, but that's the project. That's my Nerf gun shooting gallery. It works. The next version will be better, with more blinking lights, because you always need more blinking lights. Yeah, it was going to have another LED on the other side, but it was stupid o'clock in the morning and I couldn't be bothered to solder them. I'd also like to put an LED actually on the back of the targets themselves. You can see each one actually has a hole in it for an LED. I just couldn't figure out how to put the wiring up there without it slowing or altering the rate at which it fell or just breaking. So that's a version 3 feature. Hope you've enjoyed this. I don't put videos up that often, but if people paid attention to them, I probably would. So like and subscribe and do all the things people usually do on YouTube. And yeah, I'll see you next time.